Okay, we're going to be looking at this physics apparatus. It is called a rheostat. And a rheostat is actually a variable resistor. So it provides different values of resistance in a particular circuit. So that's it. So, but what does the magic here? This slide here does the magic. Helps you in varying the amount or the value of the resistance you are giving to that particular circuit. So now, what's the actual working principle here? Let's first of all take note of the different terminals here. So we have this one. This is the terminal A, and this is the terminal B, and of course the other side is the terminal C. But we're going to be using just the A and the B. So, and I'll explain why this one is going to be useless to us. So, but using this terminal A and B, you know your resistance ordinarily is proportional to the length of any wire or the length of the conducting or resistive wire. So now, this, if you are very observant, you notice that I have a coiled strand of wire that is being used to circulate this particular boundary or area of this particular resistor, and it's going and going, and they kept on rolling and rolling until they got to this other part of this particular rheostat. So if you now connect your wire here, and the current is going to flow through this part, and when it flows, it gets to this point where this slide is making contact with wire, and it goes through this place and then enters this metal and then hits this other terminal and go through the wire you're going to connect to that particular part here. The idea here is this: if I should move this slide a bit further and I have enough wire here, the length of wire is now longer. It means since the wire is longer, the resistance is greater. The greater the length of the wire, the greater the resistance, since they are both directly proportional. So that means the current will go through this one and take a longer time to get here. And when it hits this contact position of the slide to this coiled resistive wire, then it will now go through this part. But if I should move it this way, close to where the current is coming from, then I'm reducing the length of the wire here. So the length of the wire between this terminal and this point of contact is now very small. Since it's now small, it means the resistance is also small. Don't forget, the smaller the length of wire, then the smaller the resistance. Then the greater the length of wire, then the greater the resistance. So the length of wire now between this terminal and this point of contact again is now so long. And now that it's long, it means there is more resistance. The greater the length of wire, the greater the resistance. So it's going to go this way. So the greater the length of the wire, the greater the resistance from the rheostat. So don't forget, the current goes through this point and then moves and then hits this point of contact and goes and then goes through then to this terminal. So now, why this terminal and this terminal will be null and void for current is there will be complete resistance, because the current will just flow through this one. If you connect a wire from here and to this other part, there's no other metal like this here. So it just goes this way, giving it more resistance. So no matter how you slide, when it hits here, there's resistance here. When it hits here and starts moving through this one, there's another point, there's now resistance here. Since due to the coiled resistive wire, then nothing is even hitting here, because you don't have any current to flow from here to here, due to the fact that this metal is not even constructed on this part of the rheostat. So this and this is a no-go area, but this will be there in case you want to use this terminal and this point here. But this rheostat is not constructed that way, where you have a terminal here and another terminal here, in case you want to have this one as your terminal B and this one will be your terminal A, or this one will be your terminal C rather, and this one will be the terminal A. But this is a different kind of rheostat. Anyway, it's called a linear rheostat because of the way the current is going to flow this way and hit the other terminal. So let's see how this terminal is going to work. We're going to connect some wires, use our battery, and see how the rheostat is going to work. Don't forget, the more I reduce the length of wire between this terminal and this slide, then the lesser the resistance. If I should increase it, the length of wire between this terminal, see the wire is now looking longer here, between this terminal and this point of contact of the slide, then the resistance is now more. The higher the length of wire, the higher the resistance. Then the lower the length of wire, the lower the resistance. So let's quickly make our connections now. I have my wires with me. So I'm going to connect here. That's it. So quickly, let's be fast. I don't want the video to be too long. So make the connections. So one wire is connected here. Okay, so this is the connection, and if you notice, connected a wire through this terminal, then through a key so that I can put off and put on the current flow, then connect to the battery. And don't forget that this terminal of this particular rheostat must be connected to the positive terminal of the battery. That is this part of the battery. So this is the part of the battery I placed this way, this part of the battery. Then, so since the positive must be connected to the positive, then the negative must be connected to the negative terminal of this ammeter. As you can see, this is the negative part. See the minus written there, negative part of the battery. So this is the negative part of the battery, and it's this way. So the wire is being connected this way to the negative part. Then I have the 0 to 3 scale, but I want to use 0 to 1 scale so that it will be very visible. You see how the indicator is going, yes, than when I'm using the 0 to 3 scale. So then the negative, then the positive now goes this way to this other terminal. So don't forget, the positive part of the battery is connected this way to a key. Then the key is neutral, so there's nothing like negative or positive on this particular key here. So this is the plug here for the key. So once I connect it, it means I want to allow current to flow through this particular circuit I've created. So this is the plug. I've not connected yet because I'm not ready to show you until I'm done explaining. So this is the terminal here, then this way, and we are good to go. So by the time I close the key, you're going to see that now I didn't vary the length. So now there's the length. In fact, there's 0 length between this terminal and this particular contact of the slide. So the current will be high. That means there's no resistance at all. Remember, the more I slide, the more the resistance I'm creating. So let me not slide yet. Let me just leave it this way here first of all, and see the value of the current I will get using this ammeter. So let me close up my key and let the battery have good contact. So you can see from the indicator, so you can see the ammeter, see the indicator moving towards 0.8. So let me move it a bit closer. So you see 0.8. So the indicator is moving towards 0.8 because I've not varied the length yet of this particular resistive coil. So now let me unplug my key and let me now vary the length. Let me create a particular distance between, sorry about that, the terminal and this slide. So okay, let me go this way first of all. So there's now a little distance between this point of contact and this terminal. So the length of wire is small, but let's see if there's now resistance. Remember, if there's a length of wire between this contact and the terminal, it means I've created some form of resistance. But let's see whether, since I've increased the length, whether the resistance has increased. And if the resistance increases, you know that the current will also reduce, because current and resistance are inversely proportional. The more I'm increasing the resistance or the length of the wire, the more the current is reducing, and that means the resistance is already showing up in the circuit. So I've increased the length a bit, so let me now connect my plug key, then make very good contact with my battery. As you can see, it has even gone down drastically. It was 0.8 before, now it's close to 0.2. Yes, or 0.17, something like that. As you can see from the indicator, it is now 0.17 because I'm using the scale up, not the scale down. No, I use 0 to 1 scale. So I'm going to read from the scale up. It is 0, 0.2, 0.4, 0.6, 0.8, and 1.0. So now that I've reduced it, can you see? So let me now increase again and see whether the current will also reduce. So I increase again further. Let's see. Okay, the block is still there. So, it has reduced to 0. This 0.13 or 14. This 0.13 or 14 if you check very well. So the more I increase the length of the wire between these contacts of the slide and the terminal, the more the current is reducing. So let me increase it again. Let me vary it again. Let's see. So now there is more length of wire. That means there's more resistance. And that means since there's resistance, more resistance to the flow of currents, the current will actually reduce on this ammeter. So let's see again. Wow, not even up to 0.1, maybe 0.9. As you can see from the indicator, it didn't even get to 0.1 this time. It's now 0.9 because I'm increasing the length of the resistive coil. The more I increase the length, the more the current is reducing and the more the resistance it is creating. So that's just the working principle of this rheostat. It's very easy. If you are able to come in contact with one and some connecting wires and your ammeter and your battery and your key, you can try it out yourself. God bless you.